Hi team, welcome to Wiggins Maths. In this video we're going to be having a look at the numerical method called iteration. Now this is something you would have come across in your GCSE, but we're going to go through it in a little bit more detail. So, what exactly is iteration? It is the ability to take the output from your answer, substitute it back into the iterative formula, and the idea is that it's going to get closer and closer and closer to the actual root of the function. Either that, or it's going to get further and further and further away. Now, if it gets closer and closer and closer to a root, we say that it converges. It converges to a root, and if it doesn't, then we say it diverges. It's a divergent sequence. Okay, there are two possible things that can happen if it in fact converges to a root. But before we do that, we may be asked to write something in iterative form. Now, normally in this type of question, it will say show that. Okay, now it's a really important thing that it does that, because in fact there are a few different ways of writing this in iterative formula. So I'm going to show you the different ways. In essence, what we try to do here is we try to make x the subject. Now, sometimes that's really straightforward, sometimes not so much. But what we can do here is I could take this function. We want it to be equal to 0 because we want to be finding the root, or a particular root of this function. So we'll always start off by setting f of x equal to 0. Now let's have a look at how we can make x the subject. So I could write it as x squared subtract 1 equals x. That's made x the subject. It could also be written in a slightly different way. So I could write this as x squared equals x add 1. So therefore x is equal to the square root of x add 1. So that's a possible way of making x a subject. Or finally, it could be written like this. But don't worry, as I said, in the exam, it will tell you what it's trying to get you to make. So x squared subtract x equals 1, and then we can take a factor, x subtract 1. So therefore, x is equal to 1, like that. Now, the only difference here is when we turn it into iterative formula, we make the subscript of x n plus 1, and any x's in the function itself will be xn. Okay, because then what happens then is we take our answer from our output, and then that substitutes back in to the for the input for the next term, and hopefully it will get closer and closer and closer to a root, or in some cases it will get further and further and further away from a root. So let's just have a look at what actually happens, and we're going to look at each of these three cases. So we'll notice it's very similar to one of the examples that we did. We will be told the iterative formula, or it could be part of the show that from the previous part of the question. We'll also be told an initial value, x0. So what I want to do here is I want to show you what's actually happening as we continue to use our answer and substitute it back into the formula. So if we were to take our original value of x0 is 0.5, and if I was to draw up to the curve, the idea is what that will then do is that we'll place it back into the function, and then this becomes our new input, and then we substitute it in, and then that value becomes our new input, until eventually we get to our root, and our root is here in this case. Okay, so that is where, you know, f of x equal to 0, or when we set the function equal to the line y equals x equals x plus 1, the square root of x plus 1. So this is called a staircase diagram, and you can see it looks a little bit like a staircase. Okay, so this is where it will converge to a root using something called the staircase diagram. Okay, but what if we were asked to write it in this form, and we were told this as our initial value? So what will happen this time is our initial input is -2, and we're going to go down to our function, and then we're going to join that up to y equals x, and then back down to our function, and then back across to y equals x, and then back up to our function, sort of, and then back to our line, to our function, to our line, to our function, to our line, and you can see that this is spiraling inwards closer and closer to the root of our function, and this is called a cobweb diagram. Okay, again, this is for a convergent iteration, and that will be pretty obvious when that is the case. Okay, and then finally, what happens if we have another form of iteration and it actually produces a divergent iteration? So again, we've got our initial value here, okay, and that goes to there, and then we go to our line, and then we go back to our function, and there, and then as we can see, it just sort of goes off. Okay, it doesn't actually focus in on one point. It ends up going away and away and away and away and away, and never ever gets to a particular point. So that is what iteration actually does. So just by watching this video doesn't mean you'll instantly be able to do it. You need to make sure you practice. The more you practice, the better you will become. And of course, amateurs call it genius, masters call it practice.